So good afternoon. Welcome everyone to this week's Cure Cancer Lunch and Learn. I am Nikki Kinloch. I'm the CEO of Cure Cancer, and it's a pleasure to have you all here today. Today we're talking to Dr. Ben Wylie. Ben is one of our new cohort of researchers for 2024, which we're very excited about. And Ben is based over in Perth at Telethon Kids Institute at the University of West Australia. I'd also like to thank our Barbecue fundraisers, who some of you I know are on the line today, for helping to raise those funds for Ben's research onto childhood sarcoma. If you are interested in setting up your own barbecue, the link to register is in the chat box. This session will last about 45 minutes. If you do have any questions, and I would encourage them, it's always good to hear from others rather than just myself, please drop those questions into the chat. You'll find that at the bar, normally situated at the bottom of the Zoom. And send those to me and I will weave those into the conversation with Ben as we go through today. So on to Ben. Ben is a postdoctoral researcher, fellow with a PhD specialising in immunology and immune therapy. As a student, he was fascinated by the complexities of the immune system and how it keeps our bodies safe from illness. This attracted him to his current research, designing new therapies to harness the immune system to fight sarcoma and develop safer and more effective treatments. Every year, more than 75 children aged under 15 will sadly be diagnosed with sarcoma. This is an aggressive cancer type affecting the bone and soft tissue. Unfortunately, paediatric sarcoma patients are known to have a high risk of cancer recurrence, which is the leading cause of their cancer-related deaths. For recurrent cancers, treatments tend to be less effective and may cause severe and sadly lifelong side effects. Dr. Ben Wylie has recognised the potential of mRNA, an emerging technology famously used in the COVID-19 vaccine, to address this problem. Young patients will benefit from this Cure Cancer funded research, as they will receive safer and more effective treatment and will be able to hopefully return home to be with their families sooner, which is what we all want. So welcome, Ben. Thank you for joining us today.
Thanks, Nikki. It's great to be here.
So before we kick off, we've got a video in the background there. Do you want to just talk about what's happening in the background?
Yeah, so I'm in the Discovery Centre at Telethon Kids Institute today, and it's an area for our young, would-be scientists to come in and learn about your immune system and everything that goes on in your body to keep it safe, from disease and from harm. It's an area that I would have really loved to be able to visit when I was a kid. I think it would have been really cool. And today I've got our live feed of the lab here, where you can see some of our researchers are at work upstairs.
Well, this is a first. So we've not only got a chat, but we've got a lab tour at the same time.
Yeah, it's nice. So unfortunately, we can't have these kind of meetings in the lab itself, but this gives you a window into what's happening upstairs.
Wonderful. Well, thank you for that. So before we dive into your research, let's find out a bit about Dr. Ben Wylie.
Yeah, so I think you sort of covered it very briefly in the intro, but I've always been fascinated by how things work in nature and the world in general at large, and what goes on to make things tick over every day the way that they do. And that kind of took the form early in my life about in terms of going out into the environment and looking at animals and plants and things like that. And then sort of as that progressed and I ended up at university, I wanted to learn more about the human body and how it worked, and that was really an area that fascinated me. So I studied biomedical science at university, and it wasn't really until maybe second or third year uni where I guess you could say I had that light bulb moment where I attended my first immunology lecture, and then I was hooked. Like it was just, like I said, a light bulb moment. I was fascinated by all the things that were happening in my body on a microscopic level to keep me safe from disease and bugs every day, and I wasn't even aware that it was going on. So and as I learned more and more about the complexity and the intricacy that goes on in that system to keep us safe, yeah, I knew I was hooked. So that was
Brilliant.
really where I knew then that's kind of the area that I wanted to really focus in on for the rest of my studies. And then I guess at the end of university, I was looking for an area where I could, could apply that immunology knowledge, continue learning and continue discovering, and the application that I came across that really where I thought I could have a really big impact and also apply that interest in immunology was in cancer research. And I was, I think, lucky at the time that I was coming into the workforce as a research assistant, and all of these big studies were just coming out of the USA, the first sort of reports of clinical trials with immunotherapies and how successful they were in really advanced and serious cancers like melanoma and lung cancer.
Mm.
And so it was kind of a perfect storm really for me. I came in at a perfect time to work in an area that I'm really passionate about, and it was an area that was just taking off and really sort of catching fire. And that's, the application of using your immune system to detect and fight cancer, which is what really my research revolves around now. And so, yeah, I worked for a couple of years until I decided I really wanted to go back and continue studying, and I enrolled in a PhD program here at the University of Western Australia, and took up a project with a supervisor here at Telethon Kids, and that was very much focused on looking at how your immune system and the particular cells in your immune system that detect cancer, how they do that, what I guess goes wrong when the cancer actually escapes the immune system and can grow in your body, and then looking at ways to sort of overcome that or fight back against the cancer. Cancer is very smart. It comes up with a lot of different ways to evade the immune system. The more we can understand about those mechanisms, the better treatments we can kind of design.
Yeah, absolutely, that makes sense. And can we just go back to immunotherapy, because as you touched on, it has grown significantly, this type of research and work and treatment. You mentioned succinctly about how using the body to combat treatment. Can you explain a little bit more about how immunotherapy works for those that aren't quite familiar with it?
Sure. So at a basic level, your immune system works to detect foreign entities in your body, say viruses, bacteria, and other bugs that might cause illness or disease. Cancer is a little bit tricky because cancer arises from a cell in your own body, right? So it is actually still part of you, but it is very different. So cancer cells, as they grow and they mutate, they start to look very different from the normal healthy cells in our body. And some of those changes can be detected by the immune system. Okay, so in certain cases, there have been like anecdotal accounts from patients who have had cancer and then have had something happen, and say something like they had a viral infection while they had cancer, and then all of a sudden their cancer started to shrink, and something happened, and that was mediated by the immune system. And so it took a very long time for us to sort of realize that those anecdotal bits of evidence were actually were proof that the immune system could detect and fight cancer cells as well as bacteria and viruses and other things like that. So once that understanding really came about, then people were very interested in understanding how they could use the immune system. Your immune system is made up of, a number of different cell types that all perform very precise jobs in your body, whether that's detecting pathogens, whether it's mounting a very early immune response, whether it's coming in later and really doing the job of clearing away an infection or something like that. And so by understanding all that complexity, we can really break down the best cell types to use to fight cancer cells as well, and the best way to activate your immune system. And that's what most of these new immunotherapies do. So they either focus on taking the brakes off the immune system to allow it to do its job really well, or really putting your foot on the accelerator to push the immune system and fire it up to be able to attack those cancer cells.
Great, that makes sense. Thank you for that. And before we go into the mRNA treatment, etc., can we just talk about sarcoma? Obviously, you're not a clinician, but from a research perspective, in my introduction, I talked about you looking at people under the age of 15 and the impact there. Could you, in lay terms, describe more about what sarcoma is And also then why it seems to be affecting younger patients as well.
Yeah. So yeah, sarcomas are a broad range of cancers. They affect what we call the connective tissue of your body. So that's everything that makes up the structure of your body. That can be bones, it can be muscles, it can be fat, it can be other sort of connective tissue around your body. And so sarcomas are can be very different depending on which part of your body they arise in, and that's part of the complexity of fighting this kind of cancer. Now, in pediatrics, so in pediatric oncology, sarcomas are actually the third most common pediatric cancer, and they affect a broad range of kids, all the way from very young kids right up to sort of the early adolescent teenagers as well. And it's interesting because, you know, they make up 15% of pediatric cancers, but really in adults, they're very rare. So I think it's only about 1% of adult cancers are sarcomas. And so in the adult setting, there's a lot less of a focus on sarcoma compared to things like melanoma or breast cancer or lung cancer, which are very prevalent. And that means that there's not that trickle down of research going on from the adult sarcoma setting down into the pediatric setting. So a lot of the work that we're doing, we're actually pioneering it in the pediatric setting because it's such a relevant cancer for kids.
Yeah, I mean, that's very important, and we don't think of it that way, but the trickle down effect from treatments for adults and the impact it has on youngsters and pediatrics is missing. Do you, and you may not know the answer to this, but do you know why, or do you have a hunch as to why sarcomas affect those younger? Because often when we talk about cancers and we talk to researchers, those that are more senior in age are more prevalent to certain cancers because it's about degeneration of your body and your cells. Why is it the opposite generally for sarcoma?
So I think when you look at where sarcoma occurs, it occurs in the muscles and the bones, and these are tissues that are very active and growing in young kids as their bodies are growing, as they're developing. So I think, you know, my hunch would be that in these tissues there's still there's a lot going on. There's a lot of growth going on, and that leaves the door open perhaps for cancer. There's something to go wrong in those cells that could lead to a cell becoming a cancerous cell. In general, pediatric cancers arise from a more genetic basis, whereas in adult cancers and later in life, they often occur because of a range of insults or mutations in the DNA that build up over time and then lead that cell to becoming a cancerous cell. Whereas in pediatrics, you haven't had that prolonged period to develop those different mutations, so it's often very genetically driven. So it's kind of coded into those cells as an error, I guess, in the cells that could lead to them becoming cancerous.
That makes sense. Thank you. Just to say for those new guests, welcome. Thank you for joining us. I'm Nikki Kinloch. I'm the CEO of Cure Cancer. Today's Lunch and Learn, we're talking to Dr. Ben Wylie, who's at Telethon Kids Institute as part of the University of Western Australia. And we're talking about his work with immunotherapy and sarcoma. If you do have a question, just drop it into the chat box at the bottom of your screen there, and I will weave that into our conversation with Ben. So when I opened, Ben, I talked about mRNA, which some of us would be familiar with due to the COVID years. Could you, explain what that is and why it's of interest to you in your research?
Yeah, sure. So you don't need to know this acronym mRNA. You don't need to know what it stands for. You just need to know that the M stands for messenger, all right? And it acts like a signal to your immune system. In the COVID-19 vaccine, which we saw recently the development of the first sort of mRNA technology in the COVID vaccine, that messenger is telling your immune system to recognize the COVID virus and to mount a response against it. But I'm really excited because with mRNA, we can apply that same principle to cancer and to sarcoma and send messages to the immune system to activate them against the cancer. And I think the real exciting thing with mRNA, so with mRNA, we can encode the production of any protein, almost any protein in your body. Now that we've sequenced the human genome and we have all this information about ourselves, we can create a message for any signal that we want in the human body, and we can deliver that very precisely. So it allows us to develop very precise and targeted treatments to really switch on your immune system against cancer and to make sure. I think my lights have turned off. But I think it's all right. You can still see me. But by having that really precise treatment and the ability to create those really precise messages with mRNA, we can really fine-tune the response that we need. Yeah.
So you're essentially, if I understand this correctly, signaling to the body that they need to fight this cancer through this process. How do you get that signal into the body?
Yeah, so as part of our work, we've been looking at, we're very focused here at Telethon Kids in creating kinder, safer and more effective treatments for kids. We know that, these high doses of drugs we have to give to kids really can harm their bodies as they're growing. It can lead to long-term side effects, which really affect them throughout their lives. So we're very keen on creating therapies that have less impact on them while still having all the good impacts that we need in fighting cancer. One of the ways that we can do that is think about providing local treatments. So by delivering a therapy precisely where it's needed most and targeting it in that way, we don't have to give a treatment that affects the whole body and can have side effects in that way. So we've actually developed a really cool and novel way to do this with this immunotherapy gel that we've created, right? And so it's kind of, I guess it looks a bit like a hair gel in consistency and form, and it can be loaded up with different drugs, so immunotherapy drugs or other kinds of drugs. And the application for it is actually when a child comes in or an adult comes in to have surgery to remove part of their cancer. So if they have a solid cancer somewhere that's surgically resectable, when the surgeon takes out the cancer, they can actually put this gel in place at the time of surgery, and then go about closing up the surgical site and everything. And the gel then breaks down slowly over time. It's biodegradable. It's made out of natural materials that are found throughout your body. And so it's naturally broken down by the body over time, and that slowly releases the drug that's contained within. So we're able to get this really targeted delivery to the site where we know there might be cancer cells left behind. It's released slowly over a prolonged period, which means you don't get a big spike of drug all at once. And this means that we're able to provide a therapy that should have less side effects throughout the whole body, but also less side effects locally because we can give a lower dose and still be effective.
And you've touched on something that's quite important. We've talked about this before in regards to neuroblastoma and the treatment for that in kids. Again, chemotherapy can often kill the kids rather than the cancer. And one of the comments our researcher made there was that you have to do it in a way that the kid is receptive to have that treatment or that drug. So I imagine by using a gel rather than any other form of treatment, that would be very easy to administer and therefore probably more successful in treatment rather than having to give them an injection or putting chemicals in their body.
Yeah, exactly. And so we worked very closely with the oncologists and surgeons at the kids hospital here. We're located on site at the Perth Children's Hospital, which is really nice. And also with some adult surgeons in the sarcoma department across the road at the adult hospital. And that was really around designing a therapy and a therapeutic. So it was almost an engineering project to come up with a gel that was what we call the Goldilocks. It was our Goldilocks gel at the end. It wasn't too runny, it wasn't too thick, it was just right. It was perfectly fit for that surgical application where the surgeon could implant it, mold it to the shape of the surgical site. And then we really, by looking down the microscope at this gel, I suppose, we could really design the very specific parameters of the gel to release the drug over a certain time and things like that. So what it means is that, potentially in a setting where surgeons are worried about cancer being left behind as part of that surgery, potentially because it's unreachable or it's undetectable cancer, but they can put this gel in and even if they're just worried, even if they think they've got all the cancer, but they're just not sure, they can put this gel in and it's going to activate the immune system locally in that area to sort of detect and mop up any cancer that might be left behind. So hopefully that gives people the confidence that they can go away, they can get on with their life, and they don't necessarily have to have these follow-up therapies like high-dose chemo or radiotherapy. Or if we do have to give them, perhaps we can give them at a lower dose and still have good effect. Yeah.
And how long, and I suppose it's different for every patient, but how long does this slow release gel last in a patient?
Yep. So in our studies, we find that it lasts up to about 2 weeks. And as it breaks down, it's broken down by enzymes in your body, and it's just kind of recycled throughout the body. And the drug contained within is then sort of is released as the gel is breaking down. So we think, well, we have data to suggest that the drug release is kind of linked with the degradation of the gel. So by the time obviously the gel is degraded, the drug has totally been released and has had its effect. So the important thing is with biomaterials like this gel is we can really tailor them to fit the purpose and the specific drug. And so we've actually done this now with some different categories of drugs where we had to find out different ways to kind of incorporate them in the gel, and that might be binding it to I guess the polymers of the gel. So the gel, if you look down a high-powered microscope, looks like a mesh, kind of like, you know, a mesh of different little chains, and that all goes together to give it its kind of its form and its viscosity. And so depending on the drug, we might just incorporate that in the very small pores in the gel. We might bind it to those strings that make up the gel. And there are lots of different strategies we can do. So there's a lot of flexibility, and that's another thing that we really like, is that it's flexible enough for us to fine-tune it for different applications as well.
That's really interesting. And I have a question here, thank you, in regards to combination of drugs. So can you, within this gel, put a variety or mixture or change the dosage according to the patient's tumour or a cancer site?
Yes, so that's a really great question. Definitely the history of immunotherapy is that it works well in combination, and it works better when you combine multiple drugs as well. So definitely we can, and we have done this in some of our testing, putting 2 different agents in the gel at once and delivering it to see if we can get an increased effect there. The other thing I want to say with combination is that, you know, we think that these kind of local therapies where we can activate some kind of immune response at the site of the cancer can actually be really beneficial in combination with other kinds of immunotherapy. So people may have heard about checkpoint blockade antibodies, which are injected systemically around the body. And we think that our local approach could have a really beneficial effect on some of the outcomes of those kind of therapies as well. So by initiating something locally at the site where there might be cancer left behind, you're activating an immune response. And one of the real powers of immunotherapy is that you're making a systemic response. So your immune system can go all around your body and hunt out cancer cells. And so by firing it up locally here at the site where there was cancer, we empower your immune system to really go out and seek out those other bits of cancer that we might not be able to detect. And that will then work really well with a therapy like checkpoint blockade, which works systemically and takes the brakes off the immune system, just to use a lay term, I guess. So I think, yes, combination therapies are a really exciting area that we think we can be really practical with this kind of approach.
Thank you. And I was going to say, that's incredible to develop something like this that is flexible enough to work in combination with other treatments as well, to stay in your body, to seek out other cancer cells as well that you may not be aware of, and to try and destroy those. You must be very excited about the progress you have made in this research. Yeah,
it's been a very exciting project. I think I came back to work on this project because it was so exciting and because there was a real clear translational benefit. I could see, you know, if we could get this kind of therapy to work and if we could optimize all the different parameters we needed, you know, I could see the impact that it could have for patients, and I could see that it would be really positive.
A question on the use of this treatment for other cancer types. You talk about how it could seek out cancer cells, but is it possible to place this on a tumor as well, or is it only for topical on a wound from the removal of a cancer?
Yeah, so at the moment we're calling this an intraoperative therapy. So the idea is that for a solid cancer, most patients will come in and have part of that cancer removed as kind of the first step. And we kind of identified this surgery as like a window of opportunity, right? It's the perfect time. We have access to the site where there might be cancer left behind. The surgeon's done everything they can to remove as much of the cancer as possible. It's the perfect time to provide a treatment rather than, you know, the patient going away, recovering from their surgery and then having to come back later and have additional treatments. But yeah, like at the moment we're focused on, you know, paediatric sarcoma, but the application is there, I think, broadly across solid cancers, where surgery is a frontline therapy. That there's no reason why we couldn't use this kind of gel approach and tailor it for different drugs for different cancers, say, and start to deliver them during surgery as well. There are other research groups around the world who are looking at different kinds of gels that are maybe a bit thinner, that can be injected in a syringe. But for us, you know, in talking with the sarcoma, you know, oncologists here at the hospital, yeah, we're really honed in and focused on that surgical moment as the best opportunity for us to really provide a good treatment and hopefully good outcomes for patients.
Yeah, lovely, thank you. And then where are you hoping? I mean, you've touched on international collaborations, etc. But where are you hoping this treatment will go? What's next?
Well, we've just very excitingly, we've just completed a little, call it a mini clinical trial, I guess. So we worked with a vet clinic here in Perth to treat 12 dogs, pet dogs, who were coming into the vet clinic to have surgery for sarcoma. So dogs that also get sarcoma, it's fairly common. They often get lumps and bumps around on their body. And the standard treatment is for the vet to just remove that lump. But we gave the I guess the parents of these dogs the opportunity to sign up to the trial, to have this gel-based therapy at the same time that their dogs were coming in to the vet to have a surgery. And we've just wrapped up that clinical trial. Like I said, it was quite small in terms of, you know, how, in terms of like large, you know, human trials. It was quite a small trial in dogs, but it really gave us some really important information in a better surgical model. You know, you think a 30-kilo Labrador is a pretty good model for a small to medium child in terms of the amount of drug that you're giving in the surface area of a wound and things like that. So it gave us some really practical information, and it also enabled us to show that that the immunotherapy and the gel that we were combining together didn't have any adverse effects on wound healing and resolution of the surgery. So, and that's really important. Like, any time we think about the surgical context, our primary, you know, thing is that we shouldn't have any negative effects on wound healing from delivering this therapy. So the canine clinical trial has, as we call it, has just wrapped up. We're analysing some of the data from that now and hoping to publish that soon. But it's been really important, and we hope that's going to be a step along the path to starting to do this in the oncology clinic in humans as well. And I think, you know, if we can keep following this trajectory, I'm hoping to see, you know, some clinical trials with this approach using, you know, the relevant kind of drugs in the best cancer setting. We still have to sort of work out, you know, what the best patient cohort to treat in a first phase 1 clinical trial will be. But once we've identified that, yeah, we'd really like to see this in the clinic, in a clinical trial in a couple of years.
You've just touched a whole new audience now that you've mentioned dogs. You appreciate it?
Yeah, it's been very exciting.
And it's interesting. We have a researcher at the University of Newcastle. He's looking at endometrial cancer, and he actually used to be a vet, and he was studying endometrial cancer in dogs as well, and then brought that research across to female as well. So it's fascinating, that linkage too, and you know, why not solve that problem for animals that have sarcoma as well?
Exactly. Yeah. So it's been fantastic. We've been able to help some dogs with cancer, hopefully, and learn a lot about you know, how we're going to translate this kind of therapy into the clinic as well. I think more and more, I guess it's because people, you know, are willing to spend more money on their pets these days and go through things like chemo and immunotherapy for their pets. But it's also become a commercially feasible way to start getting a product to market. You know, you can enroll your drug in for a veterinary application while you're working on all those other studies and safety studies that you need to do to get a drug approved for a human clinical trial as well.
Lovely, thank you. I'm just going to pause there and welcome a couple of new guests. Thank you. Today's Lunch and Learn is with Dr. Ben Wylie. He's at Telethon Kids at the University of Western Australia, talking about his immunotherapy work on sarcomas. We've got about 10 to 15 minutes, so if you do have any other questions, please drop them in the chat and I will mention those to Ben as we chat. Moving away from the research to the lab, how you work on a day-to-day basis, who's involved in the team, and what are their roles and responsibilities?
Sure. So I guess I'll start at the top, and I'll say we have a professor, Dr. Joost Lesterhuis, who is the head of our lab group, and we sit within the Cancer Centre at the Telethon Kids Institute. And sort of below that, I work in the sarcoma research group, which is headed by Dr. Lesterhuis. And he's the one who really initiated all of this work, a number of years ago. He's a medical doctor by training who now works purely in research. So he's given the clinical way to focus on cancer research and immunotherapy. But he's the one who had this really, brilliant idea to start using the gel. I came on board about 4 or 5 years ago. I spent a little bit of time in industry working for a drug development company, but came back to work on this project. So, and then below that, I guess the other leaders of the lab are people like myself. I'm a postdoctoral researcher. And there are another couple of us who kind of head up different streams within the lab. So I'm focusing now on mRNA. I work with a guy, Dr. Wang, who is focused very much on different kinds of RNA-based drugs. And then we have a few other areas that the lab is kind of following up as well. Below that, we have a whole range of students that work in the lab. So PhD students, we have a number of PhD students who really do the majority of the lab work. They're probably here in the lab at the moment while I'm sitting here talking to you. But they do them, all the heavy lifting in the lab. And most of, we say that most of medical research now is done by PhD students. And then we have other students, master's students, doctoral students, and various levels of students who are coming through the lab as well and receiving training.
It's fascinating. I was going to say, I was up in at the Spatial Biology Centre at the University of Queensland the other day, and where I met the team, and I have to say that half the team were under 25, which was very impressive.
It certainly keeps you young. You're working with young, excited, interesting people who are, keen to and have a passion to pursue research in cancer and cancer research. So it definitely keeps us young. I have a few grey hairs now. You can't really see them on the camera, I hope, but I feel like I'm young at heart still. So and the research keeps me young. Yep.
Lovely. And then let's just move over to the funding. Obviously, a lot of our guests here know the importance of funding early career cancer researchers, or ECRs as we talk about them. What have been your challenges in getting funding and recognition for the work that you're doing?
I guess it's a big change coming from, being a PhD student and really working on one project, very focused on one project, and having supervisors and mentors to guide you through that process. Once you come out into that ECR role or early career researcher role, you're very much spreading your wings and trying to learn to fly as an independent researcher, and that can take a lot of time and learning, and there's a lot of different skill sets that really are very much a more varied and broad skill set that you need to pick up, and that is around project management, finances, and starting to run your own team and things like that. So obviously, some of the viewers will know that grants take a long time to write. We spend a lot of time writing grants to try and get the funding to do the work, and then if we're lucky enough, to get the funding, we can get back in the lab and get back onto work. So there's a lot of different things to take up your focus and your time, I guess, as an ECR, and it takes a little bit of time to work out, where to prioritize your time and how to split things up. So I think once you get that first initial funding, though, it gives you the confidence to say, people think that the work that I'm doing is valuable and is valid, and it's been peer reviewed by other scientists, and it gives you that validation to really say, yes, I'm on the right track and this is a good idea, and to really, continue with that project. So getting that early funding is really vital in your sort of ECR development. It gives you that little bit of independence as well, which is really important. Yeah,
absolutely. And we often liken it to running a small business, because you have to manage a team, you have to manage a P&L and the finances as well. It's a big change from being a student all of a sudden to not only have to do your job, but apply for funding and run a business at the same time.
Yep. And now I have a lot of students of my own, right? So I'm mentoring and supervising my own team and trying to build that. And so that's something I never really thought about as a PhD student. But it's been a really interesting part of the journey as well.
Brilliant. Question about what you enjoy the most when you get into work every day. What really drives and motivates you?
Well, it's not checking my emails and answering emails, that's for sure. No, I think scientists in general are excited by data and discovering new things and looking at data and analyzing data and coming up with conclusions and hypotheses. And so I think anytime I'm having a meeting, that might be with my students, or it might be with some of the other members of my research group, anytime we're looking at data and trying to discussing, what does this mean? What's the application for this? That's what gets me excited. So, and I think from the data comes new ideas and new discoveries that we can make. And so that's what really gets me to work in the morning, is wanting to see that new data and discuss it with everyone.
Yeah, lovely, thank you. A question here about the collaboration. You mentioned previously other teams around the world are looking at other gels, etc.
Yep.
Do you yourself, in your work you're doing currently, collaborate with any other teams or other countries?
Yeah, so not so much other countries at the moment. Definitely, we have a lot of local collaborations here in Perth and within the University of Western Australia. We work with some really great chemists who make all these gels for us and really helped us designing that first version of the gel that we made. We have obviously our clinical collaborators here at the Perth Kids Hospital, and also over the road at the QE2 Medical Centre, or the adult oncologists. We're very tied into the sarcoma research network here in WA, and that involves both community groups and funding bodies and all the researchers and the clinicians as well. And then beyond that, we're moving into new areas, and this is where we're trying to build our collaborations and tap into other people's knowledge, I guess. I'm starting to work with mRNA, as we spoke about. I'm not an mRNA biologist, I'm an immunologist, but I really want to use mRNA in these applications. And so I'm trying to build those collaborations and links with really smart RNA biologists who are going to be able to help me designing these new therapies. So we have a potential collaboration with a group at the Shine Delgado Centre at ANU. And we're tied into this. There's really an impetus now to build up an mRNA working group across Australia, where there are people who are bringing in different, I guess, expertise around mRNA delivery or biology, construction and things like that. And so we're tied into that kind of network as well. And I went to a really great conference a couple of years ago in Melbourne, which was the first mRNA Advances in mRNA Science conference, which hopefully will be held every year now. But it brought together a huge range of expertise in the field of mRNA, and I was able to learn, so much by attending that conference and talking to everyone as well. So definitely building those collaborations. In terms of collaborating around the world, we've been to a number of international conferences now and presented our findings, and that's a really good way to make those international links as well, and present our data on the world stage as well. So
yeah, absolutely. And we often hear from later stage ECRs about how the recognition internationally is so critical, not only for the progress in their research, but also to secure additional funding moving forward as well. Lovely. So before we wrap up, any last words to our audience? Anything you want to impart, let them know, talking about the future of your research or your appreciation for the funding?
Yeah, so the ECR funding that I've received from Cure Cancer Australia has been one of the most important stepping stones and milestones in my research career to date, and it's going to allow me to really build my team now and take what we think is a really great idea in using mRNA as a cancer therapeutic and really build that and gather a lot of proof of concept data to show that this is going to be a really effective therapy, and that will allow me then to get these larger funding grants as I progress in my career as well. So it's been critical for me and my research and my research team that we're building. So I just want to say thank you to everyone. If there's people online that participated in barbecue, I know I did. I held a barbecue and raised a little bit of money. But if there's people online who have raised money for any cancer research or have an interest in cancer research, I just want to say thank you for supporting the work that we do. We can't do it without organizations like Cure Cancer Australia. It just doesn't work. There's not enough funding in the system provided by the government for everyone, and so this is you guys fill a critical gap in the system that makes it possible for us to do our work. Thank you.
No problem. And on behalf of the audience here and our wider donor pool, thank you for the work you're doing. It's a pleasure to be able to fund you for the first time this year, and we look forward to seeing the progress you make with your research and all whole piece around immunotherapy as well.
Yeah, definitely. We'll watch this space, and I hope to have some really nice results in the years to come.
Wonderful. Well, thank you, Ben. You will definitely hear more from Ben as he progresses through the research, and we'll be able to share updates to you in due course. Thank you to the audience for joining us today. Please join us at the same time on the 18th of April for our Lunch and Learn with Dr. Lachlan Fennell. He is at the Monash Biomedicine Discovery Institute in Melbourne, where we will discuss his work on bowel cancer. But in the meantime, happy morning to all of you over there in WA, and good afternoon to the rest of our audience, and we'll be in touch. So we'll see you soon. Thank you, Ben, for your time. Very much appreciated.
Thank you.
Thank you. Goodbye.